Flylight Deluxe with a parachute. That must be Don's actual rig. I assume that's a real parachute in there.
Feels like it. It's probably Don's personal harness. Man, what a great thing to do to spend your R&D dollars on a hang glider. This is awesome.
The best thing in flight training is like
I love that sound. Like big bongos. The big bongo skybird.
no, you can't thermal. It's just dead air.
It's glass air.
Fast, smooth, eh? All right.
It'll just kind of stall going up. It will stall. Stall's kind of interesting.
You know, I was in a C5A simulator out here at Moffett when they got up.
So this is using the very big SGI image generators, the Onyx 2, and it's updating at 60 hertz, 60 frames per second.
Buzz the Hill.
It's full scene, it's full anti-aliasing, multi-sampled anti-aliasing, and
Speed delay.
some of the stuff I was telling you much. It's a Falcon, so it both performs and handles like a Falcon. It won't dive very well.
Fly back at the hill. Do a real tight 360 into the hill.
I should explain why A11 is an island here. When I first built this database, I had to buy both the terrain. The elevation data I basically purchased from the U.S. Geological Survey. And the way you get the terrain is it's in, oh, you mean to be diving at the ground?
Yeah.
Okay. You basically get a file format of a bunch of elevation with longitude, latitude, with posts at 30 meters apart. And then you basically have to take that and turn it into a bunch of triangles that the computer can generate.
Wow, this is awesome.
But I also took an aerial photograph by an aerial survey company, and I intermingled kind of a detailed texture, which makes it look like all that fuzz on the ground. So be a little bit more ground brush. But I didn't have money to buy all the data. The aerial photography was not cheap, and at the time the elevation data was not cheap, so I made that one.
This is cool.
So get some altitude and go out there and try doing some tight 360 or something. What was the takeoff elevation?
I don't think I'm going to make it.
2200. I don't think you'll make the LZ. You know, you never flew to the LZ, and really, the trees really have a lot of perspective when you get to the LZ. I should populate this a lot better. That was weird.
That little jump?
Yeah, that was a projector that kind of failed on us. If you look up to your left, you'll see the 600 foot. You'll see the flag at the 600
Oh, right,
foot.
right.
Yeah, that's the
God,
windsock. And
this is
then
unbelievable.
Just to your left in the center panel, you'll see the flight at the 3.
3, exactly, yeah. Anybody ever looped a Falcon?
I've landed them, probably 180. I don't think, well, I don't, Mitch has probably looped the Falcon, who knows. Mitch has looped the Skylark.
Trim's good, huh?
I don't actually think it's.
Yeah, it's pretty good. This is kind of like an inland Fort Funston with the ocean.
That's right.
This is the Bay Area in the year 3000.
That's right.
Yeah. When the world's oceans rise, you mean?
Yeah. Okay, here we go.
Go ahead and stall it. Stall it. Just push it out, stall it. It's really mellowed out. I should give you a little,
It doesn't pitch down very much.
well, there you go.
There we go.
Oh, yeah. You got the breathing and grunting thing going there. That should help.
The acoustics are really interesting. It sounds when he's grunting and grunting, I can hear it right next to my ear here.
Okay, come on, baby, get around. Stick that tip in that thermal. Yeah. All right, there it is right there. Move back around.
And I can get involved in this even from back here. I start falling over.
Stall it, yeah. There's a fundamental error in the flight model. And I've learned since that stall is not a function of lack of lift. Stall is a function of too much drag. So the flight model loses lift when it stalls instead of increasing drag.
Ah,
So the dynamics are a little bit funny.
hit the windsock.
Get enough speed.
There you go.
Whoa!
Oh!
Yeah, this is definitely cool.
So, compared to that one that you saw by the Space Needle?
Oh, no comparison. No comparison at all.
So, my comment earlier about how the control bar doesn't move,
It doesn't even affect. Don't even notice it.
do you feel like you're getting feedback from the glider?
Yeah. It definitely has a bit of inertial to it. One thing it does, the motion is a little delayed. I can't quite fully coordinate.
Yep.
Photograph.
Oh, okay.
So,
Explain that again.
so basically, the way we do trees in computer graphics is, one of the ways we do trees is by using something called billboards, which I'll show you a wireframe view of the world here. And all of these little rectangles out here are the trees, which are, there's a tree painted on it, and everything that's not tree is transparent, so you see beyond it. And the trees always turn to rotate, or rotate to face you.
And the clouds are the same arrangement.
Clouds are the same thing, so with the clouds going by up there, they're just a picture on a billboard.
SGI, what's SGI stand for?
Silicon Graphics Incorporated.
And it's the, how did you call it, the what sim lab?
This is the Viz Sim Lab, Visual Simulation Lab. Visual simulation is one of the most important industries for SGI. And this is basically something I developed as a hobby, whereas in our industry, we typically tend to market to military or commercial simulators, like things that would train either military pilots to do tactical training, or even airline pilots to teach their pilots how to do approaches to airports and experience different types of airports and get the whole experience of being a pilot, co-pilot, and charter with a good plane.
Left.
Okay, good.
So, when you think of virtual reality, you typically think of a head-mounted display. We think there's a lot of disadvantages to head-mounted display, and basically, in the industry, we've learned that it's much more beneficial to have a kind of an open spatial display here. What we have here is a curved screen. It's 160 degrees. It's 8.5 feet tall by 35 feet along the diameter of the curve. This is actually one of the more expensive displays that you can do. There's some very expensive projectors also. However, we can do this same type of display at a much cheaper way by doing, rather than a curved screen, we do something called a cave, which is kind of like a cube. You'd be sitting inside a cube, and the walls of the cube would be rear projected by projectors. Now these projectors are used because they allow us to do things like correct the distortion of the curved screen and so forth. The flat wall could be used by a simple LCD projector that you can get for doing presentations onto a PC. They're very bright. They're actually pretty inexpensive. You could do multiple walls. You could basically, around the control bar, have a display here, a display to your left, a display to your right, and if you wanted a display underneath. That would give you a very immersive environment. It will give you the open, spacious feel, not the restrictive feel of having a head-mounted display. And it's a fairly low cost, relatively fairly low cost.
Compare in size, compare what you're talking about with what we see in front of us.
So what we're seeing here is, like I said, 35 feet by 8.5 feet. We would be looking at probably 8 foot in diagonally measured. We could get 8 foot or 10 foot screens, which would make them, I can't do the math right now, but basically 8 foot diagonal screens surrounding you. And then you would need some space behind them to actually set the projector up to project onto the rear of the screen.
How far away do the projectors have to be from the screen?
They need to be quite a distance, but we basically use mirrors to make the footprint a lot smaller. I mean, the footprint would be huge if you did 3 8-foot screens, and you had to put the projector out directly behind the screen. But what you can do is build this whole thing on a small platform, put the projector underneath the platform, pointing at a mirror, which then points back at the display. And in that case, you just need maybe 2 or 3 feet behind the flat display. We're talking probably a display that takes up about, I'm going to guess at 15 by 15 feet and maybe 10 feet.
15 by 15 by 10. Well, that's
12, say 15 by 15 by 12.
By 12, good. Well, it turns out that the light truss that hangs over the display space is 12 feet, as I remember. I hope it's 12 feet. Actually, it's not solid. It's not continuous, so we'd be able to position this to miss the beams of the light truss. And 15 by 15 is certainly well within the space that they've talked about. And that's everything. That's the projectors, and then the PCs would be somewhere. They could be some distance away, I suppose.
Yeah, the PCs can fit anywhere around here.
I suppose they'd be right. You might as well.
They fit next to the. They basically take up a small space.
Here, what's the value of what you're basically offering to give to the museum?
Yeah, typically a piece of software like this runs on a software package provided by SGI it's basically free. But the software itself, the development time to actually build the database that you see here, which has Ed11 Park, the trees, the fences, the clouds, the flight model, all of this takes a lot of time. And if you were not selling a volume product, you were doing it on a piecemeal type basis.
An hourly basis, yeah.
It would be very expensive. This represents probably man months of work. So 2-3 man months at least, I think, of work to do this.
So we're talking about tens of thousands of dollars for the software, the programs, and so on.
If you're selling a game that's going to sell tens of thousands out of the market, then it's cheap.
Right. Of course, there is nothing out there that comes close to this in terms of realism and response
That's correct. That's correct, yeah.
Well, the PC games that we see are pale in comparison to what this does.
Oh,
I mean, certainly, it was my experience and Lee's experience that it's a powerful,
PC games are, and there are some hang glider stuff you can buy, but they're aimed at gamers, guys who have joysticks and are sitting at a single screen in front of them running their PC. It's not, you wouldn't want to call that a simulator because it only has a few pieces of it. It's a simulator. To really simulate, you need to have an immersive environment. The immersive environment really comes from a large screen display and having it surround you with your peripheral vision, having sort of a spatial awareness of the world around you. I think that's immersive environment. Immersive.
so that's the experience of the simulator, is that immersive environment where you feel it fools your senses.
Right, exactly.
And you don't get that with any of the PC games.
No, I mean, you really don't. You don't.
How about if we talked about the different scenarios? How about with a single screen? The optimum you said was 4 screens, creating a cave, and then the other end of that, with the simplest way to go, the cheapest way to go, was the single screen. How do you suppose that would feel? Is there any way you can?
By the way, there was another option to doing multiple screens, and that's just using television sets. You can use a TV screen here, a TV screen there. You probably wouldn't have a cave setup. It would be more of a flat and then an angled view out the sides.
These are the projection televisions that you spoke about.
Like a 60-inch projection television.
Yeah.
And that's a reasonable way to go. It's somewhat immersive. The disadvantage is the quality of the image. The image is not quite as good.
How far would the screens be from the operator?
Yeah, you'd be close to it. So your screen would have to be pretty close to you.
Yeah.
And when you're watching TV that close, televisions use an interleaved format, which gives that corduroy effect and kind of makes a blurry image. It's very low resolution. And it's not quite as good as what you can get out of a better display that's pumped through a non-interleaved projector. So it is cheaper, a cheaper way to go. It's an option. So if you use a single display, I mean, that's a way to go too. That would be the basic model. You have a single image generator or a single PC as the image generator, a single display, and you just put the thing in front of you. It'd just be a single flat panel. And you know, it's a doable thing. You could do some very simple tasks. What you don't get is the feeling that you're moving the room, if you will, as you're flying. You don't get the feeling that you're actually flying. You're just kind of directing this thing through a window that you have in front of you. And it would be probably the difference between looking out the window in an airliner and going up to the cockpit and looking out the panoramic view in front of the pilots out of the cockpit. So it's kind of the difference in the view that you would have.
Thank you.
The machine has, the one we're running it on has 8 CPUs and 3 graphics subsystems. 8 CPUs what? 3 graphics subsystems. So the way this works is there's a compute module down here. All the CPUs are here. And then there's a graphics module here, a graphics module there, and another one there. So each one of the displays is driven by a separate graphics subsystem. And these graphic subsystems are, well, it's called infinite reality. It's a reality derivative. So it's a lot of... Sure, it's completely upside down. So you basically strap into this thing. They project this on the front, and then you just ride this thing. You're just being thrown around.
And this was for Disney?
Disney, yeah.
They contracted to, I mean, did it go in, I mean, was it just a drill, or did they actually put it into, this is one of the rides?
This is one of the rides, in it's called Disney Quest. It's open in Orlando and Chicago.
This needs sound.
Yeah.
And what was your part in this, Don?
I was the consultant on this project.
Oh, wow.
Yeah. Well, this was one of them. There were 6 different virtual reality rides, and one was a. There was a couple of Disney themes like Aladdin and Hercules, and then there was a virtual head-mounted display sword fight that you did.
Sure.
So there's the jets. Display down, about 30 degrees.
That's true.
That would work. And you've got to rotate the projectors and everything.
Now, wouldn't that be a good thing to have? You just push a button and the thing rotates.
Yeah, that'd be awesome.
That would be nice. Okay, Scott. A new venture for you. I wouldn't ask him to.
So this is aerial photography, good to within 1 meter. It's a meter per pixel in the high-res areas. Can I verify here? Yeah, I can. So you can see a level of detail as it goes out to the horizon in the imagery.
Uh-huh.
The different colors indicate a different level of detail. And what we're able to do with the high bandwidth systems that we have is continually page in this imaging. So you've got the best detail closest to you. You can't possibly fit. I mean, there isn't an infinite amount of memory, right? So if you did the math on 1 meter per pixel, you'd realize there's not enough memory to fit 150 square kilometers of Spain into the computer.
Yeah.
So we basically are constantly paging this imagery from disk to memory to the graphic subsystem. Now, something like what we're doing for the museum, everything fits in memory, so it's no big deal. So I first got the lift over drag parameters from Bob Ormiston. You know Bob Ormiston?
You know the name.
Yeah, he's a NASA engineer. And he basically gave me the lift coefficient, drag coefficient, and then taught me what the equations are to get the performance of the glide to be correct. As you see, though, it doesn't retain energy.
No.
If you pull in and push out, it doesn't climb and zoom. That's in the next version. I should have that. I should have the correct inertial model done shortly. I'm working on it. The lighting on that one's not correct.
Just see if I can actually manage to pull off a decent landing approach. Yeah, someone that didn't know how to fly, you could expect to have their legs go the wrong way.
I've actually put a lot of people who don't fly, and I get very varied results. I get results like you saw him do, and then I get results where the guys just get in and they're perfectly comfortable with it. And I don't know what it is, but
Strange feeling.
it's the configuration on these machines are 450 megahertz, Pentium 3s, 256 megabytes of memory, an Ethernet card, and a Riva TNT2 card, which is a pretty nice little graphics card for about $150.
So this is a thought that maybe it's an alternative to the rear screen or the bigger screens, a projection or projector, video projector.
Well, it's definitely not going to give you the large view that you got before, but it's going to. I think. Well, you'll see basically as if I get this thing running here. I'll give you an idea of what you get for the low cost image generator.
We got the 3 PCs. those are the PCs themselves, and then the 3 screens. And we've got 3 mice, mises, 3 keyboards.
Yeah. Now, the whole thing can be configured to run off a single keyboard and mouse, which is what I would intend to do.
Yeah.
Picture, if you will, in this case, 3 TVs or 3 projection. You got them at basically at an angle to each other like this. And they would be abutted so that the edges would be, of the display would actually be touching here. And let's see if we can actually run. Well, big is the whole room.
Start again, say again?
So you get, basically, picture this as an 8-foot screen, right?
Right.
3 8-foot screens or 3 60-inch screens, 3 5-foot screens that you would with a television set, or an 8-foot screen or 10-foot screen as you would do with a projection monitor. And then this is basically what you would get. So you'll notice it's not quite as smooth as it was on the big machine. That's because the big machine is a big machine, right? And
So we're looking at not only screen size, but you also said this is not 60 hertz?
yeah, this is running less than 60
This is
hertz.
less than 60 hertz.
Yeah.
So you can perceive a jerkiness to it? I'm not seeing a
Right,
jerkiness
right.
to it.
There's a bit of a jerkiness to it.
Oh, okay, I do see it, yeah.
Now,
So that jerkiness is associated with the fact that we're using simple PCs,
right,
as opposed to your giant,
right.
really massive, gnarly, big machine.
Now we have a real improvement in graphics cards over this one. This particular graphics card has been replaced with a newer type graphics card, which I haven't worked with yet. I haven't put into the PC and worked with, but I just got a demo of it this morning. So I expect with the new PC card, it's going to be much better. I mean,
In what way?
It's going to be
It'll smoother.
much smoother.
Yeah.
Much smoother. Now, if you,
So
to
the bigger
trained eye-
machine was faster in terms of the processor speed. And what other differences between these PC units and that giant difference? We mentioned hertz, which
resolution.
turns out into a jerkiness, I guess.
Yeah, resolution, image quality, and synchronization of each of your channels. So, to most PC gamers, this is going to look great, right? To most people who are into high-end simulation, this is going to look horrible. So, but actually, it's good enough.
Yeah.
It's actually good enough. It's what the guy off the street would be very happy seeing. He'd be very happy doing this. So
And
this is
the
a
other difference
demonstration.
is, so when you mention resolution, that's
It's a little lower
the
resolution.
sharpness of the image, I
Pixels
guess.
per inch, basically.
Pixels per inch, okay.
Yeah.
So hertz, resolution, what else?
Then the synchronization between the channels. Okay, here we have
Being 3 channels.
yeah, 3 channels. We have 3 separate PCs running basically almost independently of each other, except for they have this iPoint that's being broadcast on the network. That's the only thing that synchronizes them. There's a whole lot of other things that need to be done to correctly synchronize them. But this is to the trained eye. To the trained eye, these are not synced together. To the untrained eye, they're fine.
Yeah.
Right? And somebody who plays PC games, they're used to seeing this. They're used to seeing this.